Dear students, how are you? This is Moshumi Das Gupta. I am going to discuss with you some creative question from third chapter of first paper. Third chapter of first paper is a combination of different topics. It's like SPDF block element, hybridization, Poisson's rule, and hydrogen bond. That means it is a basic of chemistry. From this chapter, today I am going to discuss with you about some creative question of SPD block element. So, hope all of you will watch the class from first to last to clear your conception on these topics. Let's start the class. Students, this is our creative question. Here it is giving element and electronic configuration. Element A, electronic configuration is 1:2, 2:2, 2p6, 3:2, 3p6, 3d10, 4:2. Element B, its electronic configuration is 1:2, 2:2, 2p6, 3:2, 3p6, 3d10, 4:1. And element C, its electronic configuration is 1:2, 2:2, 2p6, 3:2, 3p2. So students, our first question is, though A and B both are D block elements, but one element between them is transition element. Though A and B both are D block elements, but one element between them is transition element. Analyze. Second question, what will be the position of A, B and C in periodic table? Explain it by electronic configuration. Number 3, between A and B, which one forms colorful compound? Analyze. These three are the creative question from this STEM. Now, let's start by first question. So, students, let's start our first question. First question is, though A and B both are D block elements, but one element between them is transition element. Analyze. Before go through this question, you must know about transition element. What is transition element? The D block elements which has partially filled or half filled d orbital in its stable ionic state is known as transition element. I repeat again. The d block element which has partially filled or half filled d orbital in its stable ionic state is known as transition element. That means for d block elements, the elements which last electron enter in d orbital is known as d block element. So any element which last electron enter in d orbital will be d block element. But every d block element will not be transition element, because to be a transition element, it must has a partially filled or full filled d orbital in its stable ionic state. Clear? Now let's discuss this by giving an example. Students, just have a look in this element. This is scandium. Its electronic atomic number is 21. Electronic configuration is 1:2, 2:2, 2p6, 3:2, 3p6, 3d, 4s. Electron first enter in 4s orbital. As here 18 electrons, so 20 and 21. That means its last electron entering d orbital. So it is a d block element. But its stable ion is scandium 3+. To form scandium 3+, it must lose 3 electrons from its outermost shell. That means it must lose its 3 electrons from its outermost shell. So what will be the electronic configuration of scandium 3+? It will be 1:2, 2:2, 2p6, 3:2, 3p6. So students, we have seen that here there is no electron present in 3d orbital. That means its last electron entering d orbital, that's why it is d block element. But its stable ions does not contain any electron in d orbital. That's why it is not a transition element. So I think you are clear about the concept of transition element. Now let's discuss about the element of A and B. The electronic configuration which is given of A is A equal to 1:2, 2:2, 2p6, 3:2, 3p6, 3d10, 4:2. Now students, if we calculate the total number of electrons here, it is 30. That means here it is zinc. So here A is zinc. You know the stable ion of zinc is zinc 2 plus. So zinc 2 plus. To form zinc 2 plus, zinc releases 2 electrons from 4s orbital. So when zinc 2 plus is formed, then its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10. So from the electronic configuration of zinc 2 plus, you have seen that its d orbital is not partially filled or half filled. Its d orbital is full filled. But in our definition, I have told you that the d block elements which has partially filled or half filled d orbital in its stable ionic state is known as transition element. As zinc 2 plus has not a partially filled or half filled d orbital, so it is not a transition element. That means our A is not a transition element. Now let's discuss about B. The electronic configuration which is given for B is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s1. If we calculate total number of electrons, it is 29. That means here B is copper. So it is copper. You know the stable ion of copper is copper 2 plus. So when copper form copper 2 plus, then one electron will be lost by copper from 4s orbital and another electron from 3d orbital. So the electronic configuration of copper 2 plus is 1s2, 2s2, 2p6, 3s2, 3p6, 3d9. So students, you have seen that in its stable ion of copper, d orbital is partially filled. So according to definition, the d block elements whose d orbital is partially filled or half filled in its stable ionic state is transition element. As copper has partially filled d orbital in its stable ionic state, so copper is a transition element. So from our discussion, we come to a conclusion that between A and B, B is transition element, but A is not a transition element. Though both A and B are d block element because they are last electron entering d orbitals. So this is the end of our first question. Now started our second question. Students, our second question is discuss the position of A, B and C in periodic table by their electronic configuration. So first of all, we write the electronic configuration of A, B and C. First of all, A. You know A is zinc. So you can write here A is zinc. Its electronic configuration which is given in STEM is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2. Actually, to determine the position of an element in periodic table, there are some rules. Between them, the first rule is to determine the period of any element, we must see the highest number of principal quantum number. That means we must see the highest number of energy shell. The highest number of energy shell will be shown the period of an element. Just look at here. Here, how many energy shell is given? First energy shell, second energy shell, third energy shell, and fourth energy shell. Between them, fourth energy shell, that means 4 is the highest value. So the period of zinc is 4. Now, to determine group, so here I have written that period of zinc is 4. To determine group, you know students, when last electron entering d orbital, then to determine group number, the rules is we must add the total number of electrons present in d orbital and s orbital. That means n-1d and ns. So if we determine the group in this way, then what will be the group number of zinc? Just look at here. Here 10 electrons are present in d orbital and 2 electrons are present in s orbital. So total number of electrons which are present in d and s orbital is 10 plus 2 equal to 12. So here group number of zinc is 12. This way we determine the position of zinc in periodic table. Now come to B. You know from our previous conception, B is copper. Its electronic configuration which is given in STEM is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10 and 4s1. That means it is just like before one. So here you have also seen that the highest number of energy shell is 4. So highest number of energy shell is shown the period of that element. As here highest number of energy shell is 4. So its period is 4. That means here the period of copper is 4. Come to group number. Same way, you know students, same way when last electron entering d orbital, then to determine group number we should add total number of electrons present in d orbital and total number of electrons present in s orbital. That means here 10 plus 1, it is 11. So here group number is 11. Now come to C. Students, you have seen that C, the electronic configuration of C is 1s2, 2s2, 2p6, 3s2, 3p3. So if we add total electron, then it will be 10, 12, 15. That means you know here C is phosphorus. Now here highest energy shell is 3. So the period number of phosphorus is 3. Now to calculate group number, what will be the rules? If last electron enter in p orbital, then to determine group number, the rules is we should add total number of electrons present in s orbital, present in p orbital plus 10. That means s plus p plus 10. So here 2 electron plus 3 electron plus 10. So 2 plus 3 equal to 5 plus 10 equal to 15. So here the group number of phosphorus is 50. So this is the rules to determine the position of element in periodic table. I think students, all of you are clear about the position of A, B, C in periodic table. So students, our last question is, third question is, between A and B, which one form colorful compound and why? Before going through this question, first of all, I discuss with you about some concepts about this. You know, first of all, the d block elements which has partially filled or half filled d orbitals in its stable ionic state is known as transition element. Transition elements show some properties. They show variable valency or variable oxidation number. They form complex compound. They form colorful compound. Repeat again. Transition elements show three properties. First of all, variable oxidation number. Number 2, forming complex compound. Number 3, forming colorful compound. So between A and B, which one is transition element will show colorful compound? Okay. Now you have a question. Why transition element shows colorful compound? Or why transition element forms colorful compound? To clear this, I must discuss with you about that how transition element form colorful compound. You know, transition element means the d block element which has partially filled or half filled d orbital. That means transition element must have a partially filled or half filled d orbital. When this d orbital is not form complex compound, then total 5 d orbitals remaining in same energy state. Okay, this is called degenerate state. That means before forming complex compound by transition element, 5d orbitals remaining in same energy state. This is known as degenerate state. But when this transition metal form complex compound, that means when they comes closer to ligand to form complex compound, then this d orbital is split up, and 3 orbitals go down and 2 orbitals go up. That means this will split up, and this is called non-degenerate state. So this is called degenerate state and this is called non-degenerate state. You know, the significance of our d orbitals is dxy, dyz, dzx, dx square minus y square and dz square. Between these 5, dxy, dyz, dzx will be present in lower state and dx square minus y square and dz square will be present in higher state, because according to the figure of d orbitals, you know, dxy, dyz, dzx are present between the axes. That's why their energy is lower than dx square minus y square and dz square, because dx square minus y square and dz square are present on the axis. Now, when electrons first of all enter in lowest energy state, suppose students there are 5 electrons present in d orbital, just like that. When this d orbital is split up, then these 5 electrons enter in lowest energy state. So they will enter in lowest energy state. Now, when this compound is present in front of light, that means in presence of light, these electrons absorbs energy and go to the higher energy level. This time, the wavelength which is absorbed by the electrons, the consecutive color will be shown by our naked eyes. This is the reason of forming colorful compound by the transition element. Okay. Now, between A and B, first of all, you know, the electronic configuration of A or zinc is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2. Its stable ion is zinc 2 plus and its electronic configuration is 2p6, 3s2, 3p6, 3d10. That means it is not a transition element as its d orbital is fulfilled. So as zinc is not a transition element, it does not form any colorful compound. But for B, that means for copper, the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s1. And its stable ion is copper 2 plus. Its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d9. That means its d orbital is partially filled. As its d orbital is partially filled, so copper is a transition element. As copper is a transition element, so it forms colorful compound. So the conclusion of our question is between A and B, as B is a transition element, so it forms colorful compound. So students, I think all of you are clear about these three questions. No more today. Hope all of you will remain safe in your home and practice more and more this type of question in home. Okay, goodbye.